The Amazon basin covers 5.5 million square kilometers across 9 nations. This footprint is roughly 1.5 times the size of India. This area contains over 390 billion individual trees, housing 10% of the world's known animal species, and approximately 400,000 distinct plant varieties. This biological arena has been iterating for 55 million years. Every resident species is the product of relentless evolutionary pressure, resulting in an environment hostile to any biology that has not specifically adapted to its conditions. Human survival relies on specific physiological baselines. The Amazon's lethality stems from biological mechanisms specifically evolved to bypass these defenses. We categorize these system failures into 3 modes: thermoregulatory collapse at the skin, neurochemical hijacking of the nervous system, and biomechanical overload of the skeleton. Surviving this environment requires an understanding of how the jungle systematically dismantles human physiology. Biological failure often begins before a predator is even encountered. The baseline microclimate itself actively disables human temperature control. This thermodynamic schematic illustrates how mammals survive heat stress. The body expels water, and as that sweat evaporates, it pulls thermal energy away from the skin surface, cooling the core. In the rainforest, humidity frequently exceeds 90%. Because the air is nearly saturated, sweat cannot evaporate. It simply pools on the skin, and the body's primary cooling mechanism halts. Without the ability to shed heat, the core temperature rises rapidly into the range of acute hyperthermia. This temperature spike triggers rapid physical exhaustion and the onset of cognitive impairment. As the brain's processing speed slows, the margin for error disappears. In an ecosystem that requires constant vigilance, hyperthermia-induced mistakes are frequently fatal. While the climate wears down physical resilience, the jungle's inhabitants deploy targeted, cellular-level biochemical attacks. Members of the Dendrobatidae family, such as this poison dart frog, navigate the wet floor of the canopy with high visibility. Their bright coloration is an evolutionary warning signal known as aposeismism, advertising the presence of lethal alkaloids on their skin. This cellular model shows batrachotoxin molecules intercepting a neural synapse. The toxin physically jams voltage-gated sodium channels into an open position. This prevents the nerve from resetting, resulting in a total failure of neurological communication. The immediate consequences are muscle paralysis and cardiac arrest. For a human, a lethal dose of this toxin is estimated at just 2 micrograms. The bullet ant uses a different biochemical strategy. Its sting delivers poneratatoxin, a neurotoxic peptide optimized for extreme sensory overload. On the Schmidt Sting Pain Index, most insect venoms peak and fade. Poneratatoxin, however, continuously stimulates pain receptors, sustaining a maximum 4+ rating on the index for up to 24 hours. These chemical payloads serve to fundamentally override the victim's underlying neural infrastructure. In addition to chemical warfare, Amazonian apex predators apply extreme kinetic force designed to bypass mammalian skeletal defenses. The jaguar is the dominant terrestrial predator of the basin, utilizing specific anatomical adaptations to hunt in low-light conditions. A reflective layer behind the retina, the tapetum lucidum, amplifies available light by 6 times, granting the jaguar a significant visual advantage at night. While most large cats hunt by compressing the throat to cause asphyxiation, the jaguar's biomechanical adaptation is a direct cranial strike. Its jaw generates a bite force of 10,500 psi. This pressure is sufficient to penetrate the cranium and deliver instant incapacitating trauma to the brain. The green anaconda applies force through sustained muscular contraction. Weighing up to 250 kilograms, its body mass is comprised almost entirely of muscle. Its anatomy is rich in slow-twitch muscle fibers, which are evolved to maintain high levels of pressure for extended periods without fatigue. During lethal constriction, the snake monitors the prey's breathing. Each time the prey exhales, the anaconda tightens its coils to occupy the vacated space. This incremental tightening prevents the lungs from expanding. The resulting pressure induces circulatory arrest, leading to cardiac failure. Kinetic force here is applied with surgical precision, specifically to overcome primary structural defenses. The Amazon River system introduces a separate set of biomechanical extremes. The piranha's jaw muscles are among the most powerful in the animal kingdom relative to their size. capable of generating a bite force 30 times their own body weight. The electric eel has evolved a specialized anatomy where 80% of its body acts as an organic battery. This circuit schematic shows 6,000 individual electrocytes. When fired in series, they produce a 600-volt discharge, capable of paralyzing large prey. On the microscopic level, the ophiocordyceps unilateralis fungus kills its host by hijacking motor control for its own spore dispersal. After invading the host tissue, the fungus overrides central nervous system commands, forcing the insect to a specific location that optimizes the spread of the next fungal generation. Whether through high-voltage discharge or neurological parasitism, these vectors are optimized for biological dominance.